Crash course on mechanics and thermodynamics. Learn about the fundamental principles of physics, including mechanics and thermodynamics. Certainly. Mechanics and thermodynamics are both branches of physics that deal with the fundamental principles of matter, motion, energy, and heat. Understanding these concepts is crucial to understanding the world around us, from the smallest particles to the largest structures. Mechanics is the study of motion and the forces that cause that motion. It includes everything from the movement of subatomic particles to the motion of planets and galaxies. In mechanics, there are three fundamental laws known as Newton's laws of motion, which were formulated by Sir Isaac Newton in the 17th century. Newton's first law states that an object at rest will stay at rest, and an object in motion will remain in motion with a constant velocity unless acted upon by an external force. This is also known as the law of inertia. An example of this is a hockey puck sliding on ice. Once the puck is set in motion, it will continue to slide in a straight line at a constant speed unless acted upon by an external force such as friction or hitting the boards. Newton's second law states that the acceleration of an object is directly proportional to the force applied to it and inversely proportional to its mass. This is expressed mathematically as F equals ma, where F is the force, m is the mass, and a is the acceleration. An example of this is a rocket taking off. The more force the rocket's engines produce, the greater the acceleration of the rocket will be. However, the more massive the rocket is, the harder it will be to accelerate it. Newton's third law states that for every action, there is an equal and opposite reaction. This means that if an object exerts a force on another object, the second object will exert an equal and opposite force on the first object. An example of this is a person jumping off a diving board. When the person pushes down on the diving board, the board exerts an equal and opposite force on the person, propelling them upwards into the air. Thermodynamics, on the other hand, is the study of heat and its relationship with other forms of energy. It deals with the behavior of systems that involve temperature, pressure, and volume. There are 4 laws of thermodynamics, which describe the behavior of energy in different systems. The first law of thermodynamics is the law of conservation of energy. It states that energy cannot be created or destroyed, only transferred from one form to another. An example of this is a car engine. When fuel is burned, it releases energy in the form of heat. This heat is then used to create kinetic energy that moves the car forward. The second law of thermodynamics states that the total entropy of an isolated system always increases over time. Entropy is a measure of the disorder or randomness of a system. An example of this is a cup of hot coffee left in a cold room. As the coffee cools down, the energy and heat within the coffee dissipate into the surrounding air, causing the coffee to become colder and the room to become slightly warmer. The entropy of the system has increased because the energy has spread out more evenly. The third law of thermodynamics states that as the temperature of a system approaches absolute zero, its entropy approaches a minimum value. Absolute zero is the theoretical temperature at which all matter would have zero thermal energy. An example of this is helium gas cooled to near absolute zero. As the temperature approaches absolute zero, the entropy of the system approaches a minimum value, and the behavior of the helium becomes more predictable. The fourth law of thermodynamics is not commonly recognized but is considered a natural consequence of the first 3 laws. It states that the universe tends towards a state of maximum entropy, or disorder, over time. An example of this is the expansion of the universe. As the universe expands, the amount of available energy and matter becomes more dispersed, resulting in an overall increase in entropy. Now that we have covered some of the fundamental principles of mechanics and thermodynamics, let's take a look at some popular applications of these concepts in our daily lives. 1. Automobile engines. Automobile engines use the principles of thermodynamics to convert the energy from burning fuel into kinetic energy that propels the vehicle forward. 2. Refrigeration. Refrigeration systems use the principles of thermodynamics to remove heat from an enclosed space, such as a refrigerator or air conditioning unit. 3. Rockets. Rockets use the principles of mechanics and thermodynamics to propel themselves into space. The rocket engines generate a tremendous amount of thrust by expelling hot gases out the back of the engine, which causes the rocket to move forward. 4. Wind turbines. Wind turbines convert the kinetic energy of wind into electrical energy using the principles of mechanics. 5 roller coasters. Roller coasters use the principles of mechanics to create thrilling rides for amusement park visitors. The cars are propelled by gravity and the laws of motion, as they move along tracks filled with twists, turns, and loops. 6 hydroelectric power plants. Hydroelectric power plants use the power of moving water to generate electricity, using the principles of mechanics and thermodynamics. 7 bridges. Bridges are designed using the principles of mechanics to ensure that they can safely support the weight of vehicles and pedestrians crossing over them. 8 boilers. Boilers use the principles of thermodynamics to convert the energy from burning fuel into heat that can be used to power machines or heat buildings. 9 airplanes. Airplanes use the principles of mechanics and thermodynamics to generate lift and propel themselves forward through the air. The engines create thrust, which propels the airplane forward, and the shape of the wings creates lift. 10 solar panels. Solar panels use the principles of thermodynamics to convert the energy from the sun into electrical energy. 11 nuclear power plants. Nuclear power plants use the principles of thermodynamics to generate electricity by using the heat generated by a nuclear reaction to produce steam, which then powers a turbine. 12 elevators. Elevators use the principles of mechanics to lift people and objects up and down buildings safely and efficiently. In summary, mechanics and thermodynamics are crucial concepts in physics that help us understand the behavior of matter, motion, energy, and heat. The laws and principles described by these fields of study have countless applications in our daily lives, from the cars we drive to the electricity we use to power our homes. By understanding these concepts, we can better appreciate the complexity and wonder of the world around us. And now, as promised, a poem about mechanics and thermodynamics. The laws of motion and energy make our world go round. From cars to airplanes and everything between. Mechanics keeps them sound. Thermodynamics tells us about heat and how it flows from hot to cold. From refrigerators to nuclear plants. Its principles never get old. The universe tends towards disorder as entropy increases with time. But we can use these laws to our advantage and create machines that are truly sublime. So next time you take a ride on a roller coaster or feel the cool breeze from an air conditioner, remember that mechanics and thermodynamics are what make them both a wonder. Start planning your next global adventure with ease and convenience with our Booking.com referral link. https://www.booking.com/index.html?8=7989335 is a great choice to plan your next trip. You can find and book flights, hotels, cars, and local attractions all in one place, and their price match guarantee ensures you're getting the best deal. Thank you for support our AnHub Metaverse channel, and please watch more interesting videos here.